All right, so we just completed the section on elimination with addition, and that was above us. This is the second video of this activity, and this is elimination by -1, or by -1. And basically what it means is we're going to show you how you can do it with addition and with subtraction. And so let me start off with this. Here we have two equations. We have y equals -x plus 2, and we have -x minus y equals -2. And we're saying, are these the same? And so the way we'd have to figure that out is, this is in slope-intercept form, right? Y is alone. So I'm going to try to do the same thing on this one. So I go, okay, to get y alone, if I'm solving for y, I'm going to go like this. And say, okay, to get rid of x, I'm going to add x. And if I do it to one side, I can do it to the other. And that's 0. That gives me -y equals. And I have x, because x comes before, variables comes before constant, minus 2. And that looks a lot like this, but we're still not there because the y has a negative. And to make them get rid of that, I had to do something called dividing or multiplying by -1. A lot of times we'll say divided by -1 and divided by -1. And this cancels out to 1, and I get y equals. X divided by -1 is -x, and -2 divided by -1 is +2. And lo and behold, these are the same equation. Now, the thing here is that we've been doing divide by -1. But let me show you something. 5 divided by -1 equals -5. But guess what else? 5 times -1 also equals -5. It doesn't matter if you multiply or divide by -1. It'll have the same effect. 7 divided by -1 is -7. 7 times -1 is -7. By multiplying or dividing by -1, it doesn't change the result. So what we're talking about here is I can multiply through by a negative, and it doesn't change the value. It just changes the way it looks. This equation looked different than this equation. But when we multiplied through by that -1, we ended up having the same equation. So that's what we're trying to get out here. That may sound confusing. So let's try to put it in context. So here's a system of equations, right? Usually when we solve a quick system of equations, first we want them in standard form. ax plus by equals c. I need just x and y on the same side. So I'm going to take this and put them together, right? Yes or no? Okay, and usually the first thing I want to do, graphing them seems outrageous because I'd have to put them in slope-intercept form, and I need a graph. Substituting seems outrageous because I'd have to get one of the variables alone and then do all that substitution, and that wouldn't be fun. So that leaves elimination. And the first way we were taught to do elimination is just try to add. And so if I try to add these, I get 4x. Well, that didn't eliminate the x. And if I add these, I get 1y minus 2y is -1y, and I get 5 minus 4 is 1. And people say, oh, well, now what do I do? Well, I wouldn't do anything because the whole point of elimination is to get rid of one of the variables, and when we added them, we didn't do that. We just made them look different. So, adding is out. Well, how could I see that two of my variables are the same. If I could subtract one from the other, that would eliminate it, right? And so to do that, though, I'd have to make it negative. And so what I'm going to do is I'm going to multiply the bottom of this equation by -1. And what that does is I'm distributing it through the entire equation. So -1 times 2x is -2x. -1 times -2y is +2y. And -1 times -4 is +4. And the reason why you got to remember to do that is because what you do to one side of the equation, you have to do the other. So basically I'm multiplying -1 to one side, and I'm multiplying -1 to the other side. And so while this equation looks different than this equation, they are actually the same. All that we've done is we've multiplied both sides of the equations by -1. Now we take the other equation, which we have not changed, we put it above it. And now when we go to add them, after we multiply by -1, is, well, 2x minus 2x, well, look at that. That's 0. Y plus 2y is 3y, and 5 plus 4 is 9. Did we eliminate a variable? Yeah, we eliminated x. Now I can solve for the variable that's left, that's y, the coefficient is 3. To get rid of that 3, I'm going to divide by 3. What I do to one side, I have to do to the other. 3 divided by 3 is 1. That leaves me y equals 3. I now know that y equals 3, but am I done? And the answer is no. Why? Because I have to go back and find the value of x. And so I can pick, though. Which one looks like it'd be easier to substitute in? The first one or the second one? Well, the first one, I see that my variable is alone, y, that I'm looking to substitute. So I'm going to substitute to this equation. So I'm going to take this first equation, and I'm going to substitute y, because I now know what y equals. I'm going to go 2x plus y equals 5, and y equals 3. So I'll substitute that in. And now I can go ahead and solve, because I have a variable, a coefficient, and a constant. 2, 1, 0, 1, 0 to solve. So I go minus 3 to get rid of that positive 3. If I do it to one side, do the other, subtraction property of equalities. 5 minus 3 is 2. That gives me 2x. I have to get rid of my coefficient. I'm going to divide by 2 to get rid of times by 2. If I do it to one side, do it to the other. 2 divided by 2 is 1. That just leaves me x. And 2 divided by 2 is 1. So I now know what x is. X is 1 and y is 3. Am I done? And the answer is close, but not yet. Because I need to put that system, whoa, that is having a heart attack on me. Let's try it this way. I have to put that system back into ordered pair. An ordered pair that makes it true. So my x is 1 and my y is 3. Even though I solved y first, remember all ordered pairs go x and y. So this is the solution to my system. I can check too. I can go back to the original equation and say, okay, if I plug or substitute in, I should never say plug. If I plug in 1 for x and 2 for y, or excuse me, 3 for y, 2 times 1 is 2 plus 3, that's 5. That worked. If I substitute in 1 for x and 3 for y here, I get 2 times 1 is 2, and negative 2 times 3 is negative 6, and the 2 minus 6 is negative 4. So it worked for both of them. Even though I changed this problem by multiplying by negative 1, the solution still worked for both of them. And that seems a little overwhelming, so we're going to try another one. You go ahead and try this one. All right, I'm hoping you tried it. You're probably wondering why there's a mountain in the middle of the screen here. Well, I like this. This is Mr. Nelson's saying, and I actually agree with it. So when you were a kid, you just had 2 plus 2, and you're like, oh, that's 4, and there's no other way to do it, right? That's what it is. That's what it's going to be. With algebra, the problem is that there are more than one ways to solve and still get the correct answer. And so the analogy Mr. Nelson has is if I'm here and I want to get to the other side of the mountain, well, I can climb the mountain, and that would be a lot of work, right? Climbing a mountain, depending on how steep it is. I could just go around the mountain. That would be pretty straightforward, right? I could go around the back side of the mountain, and that would be pretty, I mean, it might take me more time. Or if I was stubborn, I could just start digging a hole, and I could dig a hole or a tunnel all the way through the mountain. And so there are, in fact, I could even get on a plane and fly over the mountain. There are a lot of ways to get around that mountain. And it doesn't mean that one way is better than the other way. It depends on you. So if you're at home and you have a parent who's trying to help you, and they go, this is the way I learned it, and if it works for you, then guess what? Maybe that's the way they learned it, and that's the way you're going to learn it. So the reason why I'm telling you this is, if you notice, we wrote the problem twice. We wanted to show you that it doesn't matter what you do. What you decide to do, as long as you get to the right answer, that's what we care about. And what we're meaning here is, these are both the same problem. Again, graphing doesn't seem very reasonable. Substitution, I guess I could do that, but it would take some work. Or I could try elimination. The first form of elimination is addition. X plus 3x is 4x, y plus y is 2y, and 3 plus 13 is 16. Did I eliminate anything? And the answer is no. So addition is obviously not the way to solve this. Well, do I have any of my any of my variables that are the same? And I go, oh yeah, I have 2 y's that are the same. So if I could make one of them negative, then I could change this problem completely. And the way I'm going to make one of my y's negative, and I'll just do the bottom because that's on the bottom, is I'm going to have to multiply by negative 1. And if I do it to one side, I have to do it to the other. So we just put parentheses around the whole thing. And I distribute negative 1 through the whole problem. Negative 1 times 3x is minus 3x. Negative 1 times y is negative y. And negative 1 times 13 is negative 13. And so I have the bottom problem, and the top problem didn't change, right? So that stays like this. And now, I can eliminate. I can go, okay, x minus 3x is negative 2x. And plus y minus y, well, that's 0. So that goes away. That's my elimination. And 3 minus 13 is negative 10. And then I have to get the x alone, so I'm going to circle the variable, underline the coefficient, and say, oh, divide by negative 2, divide by negative 2. Negative 2 divided by negative 2 is 1, that leaves me x, and negative 10 divided by negative 2 is 5. And so x equals 5. Am I done? And the answer is no. But it seems pretty obvious to me which one I want to substitute it to. Do I want to substitute x into this one or the top one? And my argument to you would be, obviously the top one looks a lot simpler than the bottom one, but it wouldn't matter. So I'm going to take the top one, which is x plus y equals 3. And I now know that x is 4, so I'm going to substitute, 5, excuse me. So I'm going to substitute x in for, or 5 in for x. So I'm going to replace that with parentheses and add in the 5, which is what it equals. And now I'll solve for y, and to do that, I'm going to get y alone. Coefficient is 1, so I don't have to worry about that. The constant is 5, so I'm minus 5, and that's 0. And so I get y equals negative 2. Am I done? And the answer is no. Why? Because I have to put the ordered pair. The solution to a system is the ordered pair that makes it right. And the answer is 5, comma, negative 2. And so you're like, okay, I kind of get that, Mr. Craig. Why'd you write this one then? Well, I wanted to show you that on this one we multiplied the bottom by negative 1. But I wanted to show you that it doesn't matter which one you divide by negative 1. As long as you eliminate something, that's all that matters. So if you choose to do the top, that's okay too. And what I'm saying there is, I mean, if I had decided to multiply the top by negative 1, because it just seemed like an easier thing for me, well, negative 1 times x is negative x. Negative 1 times y is negative y. And negative 1 times 3 is negative 3. This doesn't change, so I'm going to bring this over. 3x plus y equals 13. And again, the reason why we did this is the same problem, but the reason why we did this is because we were trying to eliminate. Well, negative x plus 3x is 2x. That did not eliminate anything. Negative y plus y, though, that eliminates the y, and that's what we were trying to get, because if we get rid of one of the variables, then we can actually solve this. And then negative 3 plus 13 gives me 10. Well, last time I had negatives, this time I don't. This seems a little bit easier. All right, so I still need to get my variable alone and divide by, I get circle the variable and align the coefficient. I'm going to divide by 2. If I do it to one side, I have to do it to the other. 2 divided by 2 is 1. Gives me x, and 10 divided by 2 is 5. Hey, look at that. The exact same answer, even though I multiplied the top by negative 1 instead of the bottom. What we're trying to get at here is that you can choose to do it a different way, and you'll still be okay as long as you follow the steps. And again, I'm going to substitute. What if I was crazy and said, I'm going to substitute this into the bottom problem because I'm a glutton for punishment. So instead of doing the top problem, which is easier, which would just be add the 5 here, and then I'm going to get the negative 2, I'm going to substitute it to the bottom problem, which is going to be 3x plus y equals 13. And I want to substitute x on this. So x is 5, so I'm going to go 3 parentheses plus y equals 13, and I'm going to put the 5 in there. And 3 times 5 is 15. What happened there? Again, it's being spazzy with me. 3 times 5 is 15 plus y equals 13. Sorry about that. And then I got to get y alone. That means I have to circle the variable. The coefficient is 1, constant is 15. Get rid of that constant by minusing 15. If I do it to one side, I can do it to the other. 15 minus 15 is 0. And I get y equals 13 minus 15 is negative 2. Again, same answer. So my answer still is 5 comma negative 2, even though I went the difficult route on the bottom half. So what am I getting at with this? As long as you do it to both sides of the equation, if you multiply by something, as long as you do it to both sides, and as long as you follow the steps, you can go about solving a system of equations any way you want to. You just have to choose what you want to do. So on this next one, you go ahead and try it on your own. Hopefully you hit pause. Hopefully if you haven't hit pause, you hit pause now. And hopefully you try to solve it. All right, so I look at this. Again, graphing seems kind of rough. Substitution seems kind of rough. Elimination by addition, let's just check really quick. 5 plus 5 is 10x. Y minus 3y is negative 2y. And 2 plus 14 is 16. Did I eliminate a variable? I didn't. So addition is not going to work. Can I eliminate a variable by subtraction? Well, I look and I say, oh, my x's are the same. So I can eliminate by getting rid of one of my variables. Or making one of my variables negative, I should say. So which one do I want to make negative? My top or my bottom? Well, if I make the bottom negative, that might help here. That'll make that negative. Or if I make the top, maybe it'll be easier. I don't know. I'm going to just go with the bottom because bottom is easier for me. But if you want to do the top, you can. I'm multiplying through by negative 1. Remember, you have to do it to everything, though. So I'm going to go negative 1 times 5x is negative 5x. Negative 1, there's my 1 there, times negative 3 is positive 3y. And negative 1 times 14 is negative 14. So you notice I did it to all the terms in this equation. And the top I did not change. And now I need to eliminate. So now that I've multiplied through by negative 1, I can eliminate. And I'm going to do that by adding 5x minus 5x. Hey, look at that. It eliminated. So I don't need to write it. 1y plus 3y is 4y. And 2 minus 14 is negative 12. Now I just got to solve to get y alone. Circle the y, underline the coefficient. I'm going to be dividing by 4. If I get to one side, I do it to the other. 4 divided by 4 is 1. I get y equals negative 3. Am I done? And the short answer is, of course, I'm not done. I need an x and a y to get an ordered pair. Which one of these looks easier to work with to substitute in? I look at these and I'm like, oh gosh, this got a 14. I'm going to go with the top problem. 5x plus y equals negative 3. Again, I need to substitute in for y because I now know what y equals. And so I'm going to write 5x plus my y is negative 3 because I'm substituting the value in there equals negative 3. And now I'm ready to try to start solving. Well, let's just rewrite this. 5x minus 3 equals negative 3 because plus and minus is just minus. And now I can circle the variable, underline the coefficient, double underline the constant. And I'm going to say, okay, get rid of my negative 3. I have to add 3. If I do it to one side, I have to do it to the other. Negative 3 plus 3 is 0. I don't have to write it because I have this 5x. But over on this side, negative 3 plus 3, that's 0. But I don't write nothing because I can't leave it blank. So I'm going to go ahead and bring down the 0 to show that this side is 0. And then now I have to get rid of the coefficient. Divide by 5. Divide by 5. 5 divided by 5 is 1. And that gives me, boy, this has been giving me hard times all day. What is going on today with this? So 5 divided by 5 is 1. That gives me x. And 0 divided by 5, again, 0 in the numerator is okay. That's just going to give me 0. So, am I done? Well, I know what x is, and I know what y is, but I'm still not done until I put those into an ordered pair, x and y. So it's going to be 0, negative 3. And that is the point where these two lines intersect. All right. Go ahead and finish the activity beneath you, and we'll see you in a little bit to do the last section. Thanks.